Hello and good evening, algebra students. So we're still working on solving systems of equations, and we're in day 2 of a strategy called elimination. So today, what I'd like for you to be able to do is solve systems of equations by using elimination and to be able to multiply equations by a strategic number in order to make variables cancel out. And then we were also going to have solutions where there is only one solution, infinitely many solutions, or no solutions. So that's a really big thing that we're doing today. So first of all, with this type of problem in elimination, we are going to add one more step. So we're adding one more step. Now, many of them are exactly the same though. So the first step is to make sure your equations are set up so that like terms are vertically aligned. We need to make sure they are organized and neat. So we want the x's on top of the x's and the y's on top of the y's. So I'm going to take this 3x plus 2y equals 7 and this 10x minus 4y equals 2 and put them on top of each other. So now we're in step 2. Now notice here, neither of my variables match up with coefficients. So I'm going to have to do something. This is the new step. This right here is the new part. Multiply one equation by a number so that the coefficients of one variable are additive inverses. In other words, you are trying to come up or figure out a way, how can I make one of these variables cancel out? Because they're not already matching in amount. So I can't easily get 3x to match 10x. But I can easily get 2y to cancel out with 4y. I can take this top equation and multiply it by 2. If I multiply this top equation by 2, and remember I'm allowed to do this because I can do anything to an equation as long as it's the same on left and right, this is going to become 6x plus 4y equals 14. Notice when I do that, I have positive 4y and negative 4y, so then they cancel. These two equations are the same. I did not change the value by multiplying by 2. I didn't break any math rules. I'm just making it look a little different so that I can more easily cancel things out. This is very similar to simplifying fractions, where the same fraction can be multiplied. The same fraction can be represented in many ways. That's the same way with this equation. So after you get your two equations to where they will be additive inverses, you add them up like usual. So 6x and 10x is 16x. 4y and negative 4y cancel. You can write plus 0 if you want, or you can just leave it blank. Equals 16. Now I'm going to solve for that remaining variable. So I'm going to divide by 16 on both sides, and I get x is equal to 1. Now I'm going to take this value and substitute it back into one of my original problems. It doesn't matter which one, but like I usually say, try to pick one that you think it'll be easier to work with. So I'm going to choose the top one. That's going to be 3 times 1 plus 2y is equal to 7. Well, that's 3 plus 2y equals 7. Subtract 3 from both sides, and I have 2y is equal to 4. Okay, for my final step, I'm going to divide by 2 on both sides, and I have y is equal to 2. So now I have my two parts of my answer. I have x equals 1 and y equals 2. But remember, a system of equations represents where two lines cross on a coordinate plane. So I need to write this as an ordered pair or a point. Those both mean the same thing. So I'm going to write 1, 2 for my answer. Now, of course, we are going to want to check our work to make sure we didn't make any mistakes. So you're just going to take this x equals 1 and this y equals 2 and substitute it back into both of your equations to make sure that they balance. So I have 6 times 1 plus 4 times 2. And then I have 10 times 1 minus, whoops, I accidentally wrote the wrong equation up here, you guys. Good thing I wrote that in pencil. We have 3 times 1 plus 2 times 2 equals 7. And then 10 times 1 minus 4 times 2 equals 2. Okay, so this one is going to be 3 plus 4 equals 7. That is true. And this one is going to get us 10 minus 8 equals 2, and that is true. So we now know that this solution is in fact correct. All right, so that's just me going through the steps with you. Let's just do quite a few examples because sometimes repetition can be very helpful with getting it to stick and really catching on to the process. So step 1, make sure that your equations are organized and neat. We already have x on top of x and y on top of y. Okay, now we need to decide which variable do we want to eliminate. I'm allowed to eliminate the x's or the y's, but one of them is going to be easier than the other. Notice with the x's, these are not multiples of each other, but with the y's, they are multiples of each other. If I were to take this bottom equation and multiply it by 4, then it's going to get me positive 12 for this y. So then my negative 12y and my positive 12y will end up canceling out after I get this multiplied through. So I'm going to multiply everything in the bottom equation by 4 because when I add these two equations, I want at least one of the variables to cancel out. So that's going to get me 5x minus 12y equals negative 21. And then it's going to give me negative 32x plus 12y is equal to, oh, I almost forgot, you guys. I do have a typo on this. This should say 15. That should say negative 15 like that. Negative 60. There we go. Okay, everything is still lined up, so I'm able to add this stuff up now. I am going to get negative 27x, that's what 5x minus 32x is, and then my negative 12y and my positive 12y cancel each other out, is equal to negative 81. I'm continuing to solve. How do I isolate this x? Well, I'm going to divide by negative 27 on both sides. When I do that, I get x is equal to positive 3 because a negative divided by a negative is a positive. And if you were to put this into your calculator, you'd get positive 3. All right, fantastic. I have my first variable, but I need to figure out what y is. In order to figure out what y is, I'm going to take this x equals 3 and substitute it back into my top equation. So this is going to get me 5 times 3 minus 12y is equal to negative 21. Well, 5 times 3 is 15, so I have 15 minus 12y is equal to negative 21. And I'm going to start isolating this y. So this is a two-step equation. I need to get rid of this positive 15 first, so I'm going to subtract it from both sides. So I have negative 12y, don't lose that negative, is equal to negative 36. Divide by negative 12 on both sides. And that gets me y is also equal to positive 3. To combine these into my final answer, I am going to have 3, 3 for that final solution. 3, 3 is that final solution. Of course, we are going to want to check our work. So let's do that quickly. I have 5 times 3 minus 12 times 3 equals negative 21. Well, that's 15 minus 36 is equal to negative 21. And that is true. 15 minus 36 is negative 21. In the bottom equation, I have negative 8 times 3 plus 3 times 3 is equal to negative 15. Well, this is negative 24 plus 9 equals negative 15, and that is true as well. So I know that my solution of 3, 3 is in fact correct. Let's do that again. So we're just using the strategy of elimination with one extra step. Keep that in mind. In example A, my equations are already lined up. Now with this one, you could easily cancel either one. You could multiply the bottom by 5, or I would say -5, or multiply the top by -3. I'm going to multiply the top by -3. Now you might be wondering, why are you multiplying it by -3 instead of just regular 3? The reason I'm doing that is because this bottom equation has positive 6x. But I want these to cancel each other out when I add up. So if I only multiplied this by +3, then I would have 6x and 6x getting me 12x. They wouldn't actually cancel. So that's why I'm making this an additive inverse. Remind yourself, when things cancel, one is positive and one is negative. So let's rewrite this. That's going to get me -6x plus 15y is equal to 27. And then the bottom equation is staying the same. And then add them up. So our x's cancel, and I have 14y is equal to 42. I'm dividing by 14 on both sides to isolate this y, and remember, when a number is next to a letter, it means multiplication. So divide to get rid of that, and that gets me y is equal to 3. Now that I have y is equal to 3, I'm going to take it up here and substitute it into one of the equations. I think the bottom equation looks easier to substitute into, so that's the one I'm going to do, but you can use either one. So I have 6x minus 3, because y is 3, is equal to 15. Solve for x. So add 3 to both sides. That gets me 6x, not y. 6x is equal to 18. Divide by 6 on both sides, and once again I get x is equal to 3. All right, let's make sure that our answer is in fact correct. So this gets me 2 times 3 minus 5 times 3 equals -9, or 6 minus 15 equals -9. I agree with that. And then this one is 6 times 3 minus 3 equals 15. Well, that's 18 minus 3 equals 15, and I agree with that one as well. So I do know that my answer is, in fact, 3, 3. Again, just like the other one. Okay, we're going to keep practicing this. We're going to keep going. Okay, in example B, we have -8x plus 3y equals 8 and -4x minus 5y equals 4. You're looking for whichever one is going to be simpler to isolate, or to cancel, I mean. Well, 3 and 5 are not multiples of each other, but 8 is a multiple of 4. What I want you to notice, though, is that they both have a negative sign on them. So that means I'm going to need to change the sign of one of these equations in order to get them to match up or to cancel each other out. I'm going to multiply the bottom equation by -2, because when I take a negative times a negative, that will get me a positive, and then this negative and positive will end up canceling each other out, which is what we want for the elimination method. So let's rewrite our equations. We have -8x plus 3y equals 8 for the top one, and now I'm taking this -2 and multiplying everything inside my equation by it. Once again, I'm allowed to do this because as long as I do the same thing to both the left and the right sides of an equation, I'm not breaking any math rules. So this gets me 8x plus 20y equals -8. Add those up. My x's now cancel because I have a -8x and a positive 8x, so they go away. Then Oh, I accidentally said 20. I meant 10, you guys. Then I have 13y is equal to 0 because 8 minus 8 is 0. Don't let the 0 throw you off. Just divide by 13 on both sides, and I have y is equal to 0. Now I need to take this y equals 0 and substitute it into one of these equations. Doesn't matter which one, just choose one. I'm going to choose the top one. So that gets me, I'll do it over here, negative 8x plus 3 times 0 equals 8. Well, 3 times 0 is just 0, so that basically goes away. So I have negative 8x is equal to 8. Divide by negative 8 on both sides, and x is equal to negative 1. These need to be written as an ordered pair for my final solution. So that's going to get me negative 1, comma, 0. Now, because these are smaller numbers, I think we can more easily check these mentally in our head. So if we were to plug in 0 for y, then both of these would cancel out in these terms. And negative 8 times negative 1 does in fact get us positive 8. And negative 4 times negative 1 does in fact get us positive 4, so I know my answer would be correct. Because these were smaller numbers and easy to use mentally, I just did a mental math check there. Okay, we have 2 more examples of this style just so we can keep practicing and getting the hang of it. Our equations are already lined up. X's with X's, Y's with Y's, equal signs with equal signs. We're looking for which one is going to be easiest to eliminate. 2 and 3 are not multiples of each other, but 6 and 12 are. However, notice, both of these are positive. So I'm going to need to turn one of my equations negative so that they will cancel each other out. I'm going to multiply the top equation by negative 2. When I do that, I'm going to rewrite my whole equation. So this gets me negative 12x minus 4y is equal to positive 4. Be very mindful of your negatives because a negative times a positive is a negative, but a negative times a negative gets me positive 4. So keep those signs can be tricky. My bottom equation is staying the same. Now that I have them as additive inverses, I'm able to simplify. So I'm able to add them. So I have negative 12 and positive 12. Those cancel the x terms out. Negative 4y plus 3y is just negative y. If you put negative 1y, that's okay. It's not wrong, but you don't have to write that invisible 1. It means the same thing. So if negative y equals positive 10, then I can divide by negative 1 on both sides and get y is equal to negative 10. I cannot stop here. I want to keep going in order to solve for x. So I'm going to take this negative 10 and substitute it back into my top equation for y, because it says y is equal to negative 10, not x. So make sure you're substituting it back in for the correct variable. So I'm going to have 6x plus 2 times negative 10 is equal to negative 2. This gets me 6x minus 20 is equal to negative 2. And I'm going to keep solving for x. So I add 20 to both sides to get that away. I have 6x is equal to positive 18. Divide by 6 on both sides, and that gets me x is equal to 3. So my solution is now both of these combined as 3, negative 10. Now, this would have, this problem, I could have easily made plenty of mistakes. So I want to go back and check my work. So I'm going to substitute a 3 in for my x's and the negative 10 in for the y. So this is 6 times 3 plus 2 times negative 10 equals negative 2. Well, that's 18 minus 20 equals negative 2, so that's correct. Down here, this is 12 times 3 plus 3 times negative 10 equals 6. This is 36 minus 30 equals 6, and that is true. All right, so I know my answer is in fact correct. We have one more example of this style, and then we're moving on to the final type of problem for today. These are lined up for me already. Look at your x's and your y's and the coefficients in front of them. Which coefficients are going to be easier to eliminate? Hopefully you're noticing the x's are multiples of each other because 6 doubled is 12. Also, this is negative 6. So because one x term is already negative and the other x term is already positive, I'm not going to have to multiply by a negative this time. And instead, I can just multiply that top equation by 2. So let's rewrite these. That gets me negative 12x minus 4y is equal to negative 28. The bottom equation is staying the same. And then add them up vertically. So negative 12x and positive 12x totally cancel each other out. Now I have 5y is equal to negative 28 and negative 12 gets me negative 40. Divide by 5 on both sides, and that gets me x is equal to negative 8. Y is equal to negative 8. My apologies. Take this y equals negative 8 and substitute it back into one of the equations. I'm going to do the bottom one just because. So I have 12x plus 9 times negative 8 is equal to negative 12. Well, that's 12x minus 72 equals negative 12. Add 72 to both sides. That gets me 12x is equal to 60. To finish isolating this x, I'm going to divide by 12 on both sides and get x is equal to 5. So now my final answer is both of those put together. So I have 5, negative 8. So that is our last example for that style of problem. I just want to show you one more type, and this shouldn't take too long because they are the special solution styles, so you get to an answer with them pretty quickly. So I just want you to recall a few facts, okay? First of all, recall that if you get a false statement, such as 0 equals 8 or negative 2 equals positive 2, we know that these are not true. That's not true. So if we get a false statement as you solve this system or any system, then the system has no solution. So no solution corresponds with a false statement. If you get an identity, like 7 equals 7, or 0 equals 0, or negative 9 equals negative 9, where it's the exact same on both sides, then that means it is infinitely many solutions. So you're going to have infinitely many solutions if you get an identity. So let's work through a couple of those just so you can see how they're going to work out. Okay, here my variables are already lined up, but I do need to make at least one of them match. If I were to match my x's and make them additive inverses, I would multiply the bottom by negative 2. So let's rewrite that. I have 2x plus 6y equals 18 for my top equation. And for my bottom, I'm multiplying negative 2 across. So I have negative 2x minus 6y is equal to negative 18. Add them up. So this gets me 0 plus 0 is equal to 0. In other words, 0 equals 0. Because this is matching on both, and the way I got 0 is 2x minus 2x, 6y minus 6y, 18 minus 18, all of them canceled, then I know I have infinitely many solutions. Let's do that again and see what type of answers we can get. In example A, I have negative 2x plus 5y equals 7 and negative 2x plus 5y equals 12. Let's multiply one of those equations by negative 1 in order to make my variables cancel. So I'm multiplying by negative 1, and this is going to get me positive 2x minus 5y is equal to negative 7, and negative 2x plus 5y is equal to 12. So only the top one changed, but I had to multiply by negative 1 in order to make my variables cancel. So 2x minus 2x is going to be 0. Negative 5y plus 5y is 0. And negative 7 and 12 is equal to positive 5. This is saying 0 equals 5. We know that that's not true, so this has no solution. We have one more example, so I'll go kind of quickly through it because I know this video is running long. Here, I'm going to cancel out my x's, so I'm going to multiply by negative 2 on top and bottom because I want my x's to be additive inverses. So this gets me negative 12x plus 18y is equal to negative 34, and the bottom equation is staying the same. Add them up. Negative 12x and positive 12x cancel to get me 0. 18y and negative 18y cancel to get me 0. And negative 34 and 30 get me negative 4. Does 0 equal negative 4? No, it does not. So I know that this one also has no solution. All right, thank you so much for sticking with it, you guys. Have a great night, and I'll see you tomorrow in class.